Good morning. Today we'll be dealing with what we call our outliers to examine the effect of extreme data points in shape, center, and the spread of our dataset. We look for and make use of structure, attend to precision, and reason abstractly and quantitatively using critical thinking. Now let's go to our definition of our outlier in here. So we can say that our outlier can be said as values or some value or values that are extremely low or high as compared to the data set. Now, when we say extremely high or low, we actually try to set certain parameters that would make it such values. So in terms of characteristics and facts, we can put it in terms of our formula. So our formula, we can put it as follows. We can say that's Q1 minus 1.5 times IQR. And there's one more, that's Q3 plus 1.5 times IQR. So again, in here, Q1 is the lower quartile, Q3 is the upper quartile, where when when we say IQR, those are what we call the interquartile range, the difference between Q3 and Q1. But later we'll be dealing with those formulas as well. Our examples, we can draw certain examples in here. So usually we call it in terms of like a box plot and see that in fact the outliers are those values that are way above or way below the box plot set of data points. And obviously for our non-examples, then any value that is in fact inside the data points would definitely be non-outliers. So on our outliers, we're considering our box plot in here.
Unknown caller. Unknown caller.
So in terms of our outliers, we're considering our box plot here with the following. So in here we have our minimum value, lower quartile or Q1, our median or Q2, our upper quartile or Q3, and our maximum value. So the first thing that we're going to do, let's call it step one, is compute for what we call the IQR or the interquartile range. So to get the interquartile range, we're simply going to subtract the Q3 and the Q1 in that case. Now, after getting the interquartile range, or what we call our IQR, then our next step in here, step two, is consider first the outliers above or higher values for the outliers, and to get that, then we say the outliers are possibly somewhere beyond Q3 plus 1.5 of the IQR. And the next one, step 3, to get the lower value outliers, then we're going to get values less than Q1 minus 1.5 times the IQR. And again, Q1 and Q3 are the lower and upper quartiles respectively. So let's apply our knowledge of IQRs in terms of our examples. So let's have our first example in here. Given the data points 18, 14, 12, 14, 11, 11, 19, 20, 16, and 11, which values would be considered as outliers? So in this case, what we're going to do is to consider first its box plot. So we can consider its box plot using either our Desmos or our TI-84 calculator. So in this case, let us use first our TI-84 calculator in here. So in our TI-84 calculator, let's clear everything first and press second plus 712 to clear the random access memory. After that, we're going to go to stat, press enter or number 1, and under L1, we're going to put all the values mentioned in our problem. So in this case, we have 8, 14, 18, 14, 12, 14, 18, enter 14, enter 12, enter 14, enter. Continuing with the rest, we have 11, 11, 19, 20. So again, that's 11, another 11, 19, and a 20. And the last few will be the following 16 and 11. So that will be 16 and 11. So as you may see, we have 10 data points in there. Now, in order to get the interquartile range, we can either plot or assemble its box plot or simply calculate it. So in my case, I would simply go to plot this in our box plot, typing in the following. That will be second y equals for our stat plot. I'll choose number 1 in this case. Please enter to turn it on. Now for the type, I'll go down. For the type, I'll simply click on. Okay, so in here, the fourth one is the box plot with the outliers, and the next one is the box plot without the outliers. So in this case, let me choose first the box plot with the without the outliers in this case, and so that we can compute for the outliers later. Then after that, we're now all set with this one, and as you can see, the X list is on L1 as well. You can change the color if you want to, but in this case, I would now go to zoom. I'll now go to zoom. In this case, I will choose number 9, which is zoom stat. So just press 9 to press zoom stat in here. So as we may see, we already have our box plot in this case. But as you may see on our box plot, there's no left whisker in that case. So what we're going to do in here is to try to analyze this one first by pressing trace. And as you can see in here, the median is 14. If you press left, you can see that Q1 is 11. If you press left again, the minimum is also 11. So again, the minimum is 11. The Q1 is 11. The median is 14. And the Q3 is 18 and 20. So again, that's 20, 18, 14, 11, 11. Let us now draw our box plot in here. So according to our box plot, we can see now that this is considered a vertical box plot. The maximum is 20, upper quartile Q3 is 18, median is 14, lower quartile Q1 is 11, Minimum is also the same as the Q1, which is 11. Again, this is our what we call a vertical kind of box plot. So the first step that we're going to do is to consider the IQR, which is simply the Q3 minus Q1. And with that being said, then that will be 18 minus 11 in here, which is in fact 7. So that will be my IQR. The next one, to get the upper outlier, then I would say outlier should be above Q3 plus 1.5 of IQR. So with that, or 1.5 times IQR, so with that, that should be what? Greater than Q3, which is 18, plus 1.5 of 7. In this case, that should be greater than 18 plus 1.5. 18 plus 1.5 times 7, I got it to be 28.5. So the outlier must be more than 28.5. Now to get the lower outlier possible values, then I would have the other computation for it. The outlier should be less than Q1 minus 1.5 times IQR. So with that being said, that should be less than Q1, which is in fact 11, minus 1.5 times 7, and this will give me a zero point 0.5. So in this case, that should be an OR. Then we already have our answer in here, which says that the outlier must be greater than 28.5 or less than zero point 0.5. In this case, that will be letter D. So again, that's how we compute our outliers. So in some cases, we don't actually need to compute the outlier anymore. Like in this particular example, it says, use the information below to answer the following question. So we have the table, Lake Superior agates, and we have the following values: 101.9, 201.2, 199.4, 198.3, and 198.7. It says that some students measure the mass of a Lake Superior agate. The measurements in grams are listed, which measurement is an outlier for the results. So as we can see in here, by observing it, we can say that the last four observations, 198, 199, and 201, are close to each other, which only means that in here, without even computing, that the 101.1.9 is in fact the outlier in here, because it's the extremely low value in here as compared to the 201.2, the maximum value, which is in fact near the other values as well. So again, there are cases, or actually in most cases, we don't actually need to calculate or compute for our outliers, like in this particular case. Let us consider our third example in here. It says that Edgar earned the following scores on his first 10 science tests: 73, 86, 91, 87, 88, 79, 82, 93, 90, and 86. It says here, which of these will be affected if Edgar earns a score of 50 on his next test? So as we may see, this 50 in here is in fact an extremely low score. And we can in fact say that it might be uh, an outlier, a lower value of outlier in this case, because in our set of values in here, we can say that the minimum value is in fact 73, and a 50 is way lower than the minimum value of 73. So with that being said, if we will add this extremely low score to our set of data, then that means the mean will be lower. So again, we say in here that if a significantly low score is added to a data, then the mean, or what we call x bar, will result to be a lower value. And in fact, we don't need to actually use a Desmos or calculator to do this anymore just by observing it. But if you want to do a calculator work on this, then you can also do that one. Next one. So we know that the mean will be changed in here. The next one is our median. So in this case, since we added a low score, then that means our middle point will be a different thing already, or a different value already in here. So in this case, we say that if a score is added to a data set, then this will definitely, or actually always, change the median, because the median is always the middle term, and which means that if you added any data point, whether it will be a lower data point or a higher data point, it will definitely change the median, because again, the median is always the middle term in this case. So again, in this case, then that will be letter B for this answer. Definitely the mean will be lower, and the median will actually be lower as well in this case. But in terms of the mode, since 50 is not any of those given terms, then no term will be repeated, then that means the mode will still be the same for here. So just to verify, let us put these points in our Desmos calculator. So on our Desmos, I'll put a certain letter. Let's call it letter A, or big letter A is equal to, let's use this square bracket in here and putting everything in there. That's 73, comma, 86, comma, 91, comma, and so on. Just make sure that um, all of the numbers are separated by a comma in here. What I'm going to do now is to create another array of numbers. Let's call it letter B, or array letter B, having the same values, but I'm also going to add a 50 in there. Now for number 3, let's compare the means of this two in here. So to get the mean, we can go to our keypad, and under functions and stats, we can see the mean in that case. Sorry. Again, we're number 3 in here, and I'll just put again, you can also type in just mean, and then parenthesis of letter A, and that gave us 85.5. For to compare the means, I'll put the mean in here as well of our B, and it give me 82.27, which means the mean becomes lower. Now to get the median, I'll do the same. Again, I can also use the functions mode in here and click the median if I want to of A. Is 86.5, and the last one for number 6 in here. Once again, to get the median, I can simply type in here as well as a median of array B, which is 86. So again, the mean and the median are just the same, but the mode is not in this particular case. So for your own personal practice, you can solve for this one in here, which says the mean exam score for 31 students in a geometry class was 79. The median exam score for the same set of students was 75. Two additional students took the exam at a later time and scored 65 and 93. How did the mean and the median change when these two additional scores were included? Again, in here, 79 is the mean is the median, and two additional scores were added to the data set. What will this do now in terms of changing the mean, median, or even the mode for our case? So once again, we are already done with our topic on mean, changing the mean, and even the variability, even the shape of the data distribution if an outlier was added to a data set. Once again, if you have questions regarding our topic on outliers and how it does affect our central tendency, spread, and shape of the data distribution, please let me know. And once again, tell me quando you can do math.